Hey, welcome to the FabitTalk channel. In this series, FabitTalk, where I talk about projects I've done in the past where I don't necessarily have video for, but I do have pictures and I talk about it. In this episode, we're talking about doing something inside that should be done outside. FabitTalk.
Hello. Go.
So this is a job we did many years ago. This is what's called a gypsum calcining kettle. Right now it's sitting on its side, and that's important to this story. What this does is it calcines powdered gypsum, which is used to make stucco that you put on the side of a house, makes wallboard, sheetrock, that kind of stuff, and all sorts of different products. And this is the unit that they use to make that. Because the gypsum, after they grind it, it's raw. They have to cook it to dry out the water and make it into a very specific type of material. This is one of the types of things that we make, and we built this inside. We should have built it outside, but it was winter, cold, a lot of other problems, so we decided to do it inside. Well, this thing is 23 feet tall and 12-foot diameter. So our door is the door that you see next to it is only 16 feet wide and 20 feet tall. So it wouldn't fit out the door. So this starts out as just a simple shell that's rolled and welded together. We did do some of it outside. You can see here we're putting the shell pieces together. We did it in two halves and then we moved it inside to do actually the welding and the final fitting. What's unique here is on the bottom of this thing, they call it a reversed dish. It's a type of vessel head that used in high pressure type of situations. It's a very heavy reverse dish that goes on the bottom of these. It acts like, we call it the kettle bottom, and they're very heavy, very expensive, and it's where all the heat is, most of the heat is used in the process. So this is the unit kind of put together, just getting ready to do some final welding. Let me give you a little bit of spiel about these. So when we say a kettle, it's a heating device for a product. Not that kind of kettle. That needs to get out of here. That's a teapot. That short and stout. That needs to go. That's a kettle. Close, but there's no yummy goodness inside our kettles. You wouldn't eat it. That's closer. So it's really a pot. And you have heat from the bottom, and then you have these pipes that go on the inside like you saw in that picture. And what they do is they take the heat from the bottom and then it circulates through those pipes and goes out. And that makes it more efficient and just better at heating the gypsum inside. And that's what we call a gypsum kettle. And this fire it's a lot of fire, a lot of heat. And it does it very efficiently and does a good job. And that's a kettle. So that's a gypsum kettle. So here you can see the unit put together. What's not normal with this one is the flues, like I talked about. Normally they're just round pipes that go through there. But this customer requested a very unique type of flue where it's a diamond. A lot of weird reasons why. We didn't argue, said we can do it. So we did it. But how we made it was really neat. It's square tubing that we squashed down. And here the guys are just putting the pieces in. So these are the flues, the raw flue before we squashed them. So this is our press brake, 500-ton press brake. We use this to make them into a diamond. So if you know anything about pushing metal in between two objects, things tend to fly out. So I said, well, we need a way to hold it in safely so as we squash it, it doesn't fly out, because you're essentially doing 2 points that can, if you're not perfect, it could fly out. So if you'll see in the top portion of this, a rod with a little handle welded onto it. There's one on each end. So, and this was adjustable because they're all different lengths. What was funny about it is got it all made, got everything worked up. And then I says, hey, let me try this real quick and see if it works. So you take a tube, you set it into the die, the press brake down and slide those pins in. You lift the brake back up. The tubing would swing down to where you wanted it, to where the diamond was, or the corner was up, and then you bring it down and squash it to a set distance. And when I was testing it, I was like, well, let me try it and make sure everything works. It worked so good, I just did it. It took me about half a day. I got all of the flues bent to where they needed to be. Kind of one of those things that just a spur of the moment thought ended up working out very well. And this is what they look like after they're squashed. These were, anyways. So here's kind of a little more standing back view of it. Kind of gives you an idea of scale. The lift that's collapsed is about, it's about 6 feet tall. So now, here's the interesting part. This is where we should have built it outside. Well, you can't ship this thing. It's 23 feet tall, so it needs to be shipped on its side. Well, we're in a building and we can't get it outside. We worked with an engineer to figure out what we needed to do to flip this thing on its side. And we also worked with a crane company. And what we came up with was a single pick point. Now, this thing weighs about 70,000 pounds and had calculated where it needed to be exactly because when you pick something like this, you don't want it to fall one way or the other. So when you're picking up, you want it to lean and then stop. You don't want it to flop over that way. You could have, it's very dangerous for something to do that. So you want it to go to that right angle, and then you can let it down. And this is what we came up with. The other thing is this is in our building. Well, it is a pretty big space. You can see that beam next to the crane right there. They had to work the boom as they backed the crane in because it was such a tight space. I think this is about a 170-ton crane, which was more than enough. We also had another crane in the back. So this other crane you see, this is actually back. And the reason why we did that is it's a second pick. We put another picking point on the bottom of this kettle. So when he picked it up, when he leaned it over, they grabbed it on the back. And then it's a much safer way to pick something like this than just trying to lay it down, because there's a lot of forces when you lay something like that down if it's not up in the air. And so that's where that crane was stuffed. So this is just starting the pick, and you can see it starting to lean over. This was a very slow process. You can see how close it is to his boom. And it just starts to lean over. And then about right there, that's where it's the equilibrium of the pick. So he could either let it down from this point, which, like I said, is a little bit dangerous because this is on one point. And what could happen is if he set it down, it could try and swing one way or the other. And we didn't want that. So we came over here and we hooked up the other, there's the point. We hooked up this other crane. We'll get in here. There, he's hooked up now. And then they picked it up and laid it flat. And the other thing was, our original plan was we were going to set this down on some saddles and then drag it outside, because that's normally how we do build these inside every once in a while, but they're usually not this tall. And that's one way we do it. I actually have a video you can check out over here of us dragging a kettle outside. And so we decided the crane guys said, hey, let's just walk this out the door. So we said, okay, let's do it. And they walked it out the door. This was the final pick where they had it laid down, and then we just set it outside. Kind of a neat little thing we did. It was interesting how the initial thought was, we got to build this inside. It's winter. This is too big to like wrap it with some scaffolding or something. There's just too much work to do that. And so we said, well, let's build it inside and then we'll think about it later. We didn't have any of this planned out when we first started the project. So as this is progressing, we're thinking, coming up with plans and talking about how we're going to do this. And then we brought this is the guy running the crane. The big crane was actually the owner. And he came out, he's like, I want to do this myself. So he came out and ran the crane. And we kind of came up with this last maybe 2 weeks before we were ready to go. But it's interesting how you can kind of come up with things on the fly, and it all worked out. It worked out very well. These things have a lot of welding on them. I think there's around 600 man hours of welding on this one. Usually it's a little bit less because they're not so tall, but it's a lot of welding. And And there was a concern about doing it outside, like I said, because there's just so many other things. We've done these outside before, and guys don't like to, well, this is winter. The guys don't like to be cold, but they don't like, when it's summer even, the guys don't like to be in the sun. So you got to set up shade cloth. You got to do all these things. We always enjoy doing them inside because we have the space and we have cranes in there and things to build them. But so here it is. It's on the truck. This actually went to Germany. So it was on its way to the port. Another funny little fact about this, these are very expensive to ship. They take up a huge space on a container ship. That's how they usually get shipped. They'll leave a space out of containers and then place this where containers will go. So you're essentially paying for that whole space, that whole vertical space where they would put shipping containers. So they're usually expensive. I think at this time, I'm not totally sure what it costs because we didn't arrange it, but normally it's like $25,000 to ship these across the ocean. And this went from Houston to Italy. And what was funny is I know a little bit about VAT tax, but I'm in the US, so I don't deal with VAT tax. Well, this made it to the port in Italy, and the customer called me and says, "Hey, did you pay the VAT tax on this?" I've laughed pretty hard before, but that was a pretty good chuckle he got out of me. I says, "I absolutely did not pay the VAT tax on this. I don't even know what that'd be. I don't even know who I'd pay that to. That's on you." He told me afterwards, he says, they made us pay VAT tax at the port and when it got into the country. I think he said it was around $50,000 in taxes to bring that in. So it's ridiculous how that kind of stuff works. But I'm just glad I didn't have to pay it because I did not plan on that. That would have been a disaster. So here it is going out. So that's a gypsum kettle. This was a unique one. They don't normally look like this, but it was a fun one, and just the way we built it and how we had to flip it over, and but just a unique kind of project that we've done. So, hey, thanks for watching. Hit the like, subscribe, comment any weird projects you've done like that, or you've been involved in any projects where you've had to tilt heavy pieces of equipment on their side with one single pick. And I'll see you on the next video. Thanks for watching.
That's like, oh yes. Somebody come on here and have it, so